Everyone, today we are going to see about let n greater than 1 be a bounded sequence of real numbers such that limit n tends to infinity an does not exist. Let s l belongs to R, there exists a subsequence of an converges to u l. Which of the following statement are necessarily true? So s is an empty set. X has an exactly one element. X has exactly at least two elements. X has to be a finite set. So mm, so for given is a bounded sequence, so we have to choose a simple example for a bounded sequence minus 1 power n. So this will be 1 minus 1 plus 1. So what is to means there has to be a subsequence. So if a bounded sequence is convergence means then the subsequence also converges. So from this the yes will not be the subsequence will not be a empty set. Okay, so this option is cancelled. And x has exactly one element. If it is the minus 1 power n means it has a two form. If we take the subsequence as a minus 1 power n or 2n plus 1 means it can use the both plus 1 and minus 1 value, so it does not have exactly one element, so this option is wrong. And x has at least two element, and yet s has to be a finite set. For this, from Bolzano-Weierstrass theorem we know that any bounded sequence, it has a convergent subsequence. So it has a convergent subsequence means it should not be a finite set, so it is related to an infinite set. So we can't define that the bounded sequence has the subsequence that will be in a finite set. So this option is wrong. So it has at least it has many elements, so it has at least two element is the correct option. Then f is 0 to 1 to 1 to infinity be defined by the function 1 by 1 minus x n greater than 1. Let Pn of x equal to like this polynomial. Which of the following statements are true? F of x is not uniformly continuous on 0 comma 1. The sequence converges to f of x pointwise on 0 comma 1. The sequence converges to f of x uniformly, and the sequence converges to f of x uniformly on. So we for take a simple form, f of x equal to 1 by x. Is this uniformly continuous function? So if we draw the diagram, it will not an uniformly a continuous function. So f of x is continuous means if it is continuous means the endpoint must be tends to, and the limit must exist. So for that, so it is not a uniform function is a correct option, and we have to prove which one is true. Then Pn converges to f of x point based on 0 comma 1. For 0 comma 1 it has to convergently, there is no uniform sequence, so there is not uniformly continuous, so this option is neglected. And Pn converges to f of x uniformly on. For example, this is the open set, so it will be pointwise it will be converges, because we know the form of 1 minus x whole power 1. This is the 1 minus x whole power, and this should be less than 1 means it is converges. So it is a open bracket and it is less than 1, so the sequence is continuous. And here also for any c, so less than 1 means strictly less than 1, so it may be a 0.1, 0.9, or whatever else. So this one is uniformly continuous. From both the option are similarly true. This is in the given as a specific limit, this is contain some value, so this two option is correct. So option 2 and 4 is correct option. Next, consider the improper integrals pi by 2 to pi 1 by sin x dx. So it is improper integrals, it definitely has the beta function, and I of a is like this. So we have to find this. And for a beta function, if it is has some value means it should be converges. So from this for non-zero number the beta function will be 1 to infinity means it can be written as summation of n equal to 1 to infinity f n. So by using the comparison set test, we has to show that 1 plus n square less than 1 plus n square, or otherwise n less than root n. It could be written as n by 1 3 by 2, By harmonic test, it is convergent. By using any comparison test, a n plus 1 by a n tends to some value, means it should be convergent. And for any other term, if it is summation a n b n, if a n is a decreasing sequence and b n is convergent, means by using the multiplication it should be definitely converges. So our beta function is pi by 2 pi dx. So what we have to do means the integral ia for all a greater than or equal to 0. At equal to 0, at equal to 0 it should not converges, because at 0 point it should not converges, so it will be 0. And has some value, and not for all, not for a equal to 0, this is the correct option. So by using a beta function, if we has to integrate, means sin x can be written as root t, and if we take the derivative, means sin x is cos x, this is dx, and 1 by 2 root t dt, dx can be written 1 by root t cos x dt. And we know that 1 minus cos square x equal to sin square x, and sin square x can be sin x can be written as root t, and sin x equal to root t means sin square x equal to t. So 1 minus cos square x equal to t, and cos square x equal to 1 by t, cos x equal to root of 1 minus t. So and our dx equal to 1 by root t, 1 minus t here dt. And then what we do means, d instead of dx we have to place this 1 by 2 root t 1 minus t dt divided by here is sin x. So it is sin x equal to sin square x so it is root t. So this t getting cancelled, and it has some, if we substitute and changing the limit, means pi by 2 can be written as 0 to 1. So it has some value, the beta function has some value, means so it is convergent. So this the integral is convergent is the correct option, is not convergent is the wrong option. So 1 and 3 is correct. Hope you all understand, and thank you.